2004, and she previously presented the BBC's iconic science series, Tomorrow's World. Vivian has been a columnist for The Times, The Guardian, and the News of the World. Vivian additionally serves as head of engagement at Genomics England, which delivered the 100,000 Genomes Project, and recently completed her term as a member of the board of UK Research and Innovation, which is responsible for the strategic spend of the UK's £7 billion annual research budget. Vivian, it's a pleasure to be working with you again today, so over to you, please.
Thank you to all of you for joining us today. And my goodness, you are a huge global audience and hardly surprising given today's guest. Let me introduce Dr. Eric Topol to you. Now, I could say simply that Eric Topol is a practicing cardiologist and executive vice president of Scripps Research, or I could say that he's lead investigator for NIH's All of Us study, or that he's a best-selling author with titles like The Patient Will See You Now and Deep Medicine. Or I could just tell you that he's the author of over 1,300 peer-reviewed articles. That he's all of these things is astonishing. But emerging from the pandemic, there's something else. For nearly 750,000 people on Twitter, or if you must, X, he's the now trusted guide to new science, which he presents with great clarity and humility. Now, Eric Topol has always been a visionary. His college thesis back in 1975 was on gene therapy, and some 25 years ago, he saw what AI might do for medicine, and it's been a defining element of his career ever since. And unpacking its impact and potential in healthcare, particularly in medical forecasting, is the subject of our forum today. Eric, we're so pleased to have you with us.
Thanks for your kind introduction.
And I guess what unites all the elements of your extraordinary career is your ability to integrate multiple data points and infer what they all mean for the future. And I wonder whether it was that first drew you to the potential of AI all those years ago. And can I just say, at that time, there was no supercomputing or high-speed computing. There were no wearables. There were no iPhones.
Yeah, I think kind of growing up with the data exponential growth, it became more apparent over time that humans weren't going to be able to deal with this, that we needed some new tools. And so when we had the genome, that was, of course, sequenced in 2000 or in the early 2000s. That was one part. But then when we got sensors, and as you mentioned, with broadband and smartphones, it just was a total tsunami of data that it's not possible for us to deal with. So that spurred the marked interest in AI. And obviously, we're making big strides. I mean, just in the last couple of years, this thing has just gone into an acceleration that I don't think anyone could fully envision.
Now, we talk about AI in healthcare very often as if it's something in the future, but of course, it's already here. And there are multiple examples of AI that's in use and has been approved. Can you just give us a couple of examples there?
Well, there's already almost 650, 670 algorithms approved or cleared by FDA. Most of these are imaging AI algorithms, but that just shows you that there's been a lot of, in the deep learning phase, this is prior to where we are now in the transformer generative AI. There was just a huge number of algorithms that showed we could interpret scans with the help of AI far better than we could as clinicians or radiologists. And that includes, of course, pathologists too. So this is really the first phase. But right now, of course, it's going in this, as we'll discuss, this multimodal large language